In this demo, I will show you how to set up a basic network using GNS3. I will show you how to set up static routes between routers. We will also analyze the ARP and ICMP protocols using Wireshark. And we will start everything from scratch using GNS3. Let's add routers to our network. Let's use the C3725 router. Let's put an Ethernet switch in between the routers so that you can easily hot swap more PCs or more routers to the switch. We can also add a couple of VPCs to simulate PCs on our network. Let's connect all these network elements using the connection tool. And we'll pick the available interfaces to connect. It doesn't matter which one you pick. So that should wrap up the connection. So once that is done, we can go and close the connection icon on the left. So our goal is to see if we can establish connection between PC1 and PC2. Let's change the name of the router to R1, the first router to R1, and the second one to R2. So once that's done, let's start just highlight the labels so we can see the different interfaces. So it will be easy for us during the configuration using GNS3. So now that we've done everything, we can also label the IP addresses we'll be using in the scheme. So let's add a label and we'll come up with some IP addressing. So let's set the PC1 to 192.168.0.2 and let's keep the gateway, the R1 as the gateway, and the IP address for that will be 192.168.0.1. And then so on the other side of the router we will pick another network. So we will go with the 10 network. So we'll do 10.0.1.1 network, and then now to the R2. So we will pick .2 for that router. So we'll use 10.0.1.2. And for the other side of R2, let's pick address in the 172 range. So that will be the gateway for PC2. So for PC2 we can use the IP address 172.168.0.2. Okay, so now we have all the labels. It's easy for us to refer while configuring all the network elements. Let's go connect to all these devices, configure the IP address of the PC, which is 192.168.0.2. And we'll also configure the gateway. I mistyped the router gateway address, so let's fix that. So now the PC1 is assigned the IP address of 192.168.0.2. So let's go to the router R1 and we will configure the interface F00 and F01. So go to config T in the router to go to configuration mode. So let's go to the interface F00 and then we can add an IP address of 192.168.0.1 with a subnet mask of 255.255.255.0. So you have to type address there. And then do a no shutdown to bring up the interface. So whenever you do a no shutdown, it brings up the interface. And let's configure the other interface, which is F01. So let's go to interface F01. And then the IP address for that is 10.0.1.1 as you see in the diagram. And the subnet mask again is 255.255.255.0. And we have to do a no shutdown on each interface to bring up the interface. So let's check that. I'm just excluding all the unassigned IP addresses so we don't see it too many with interfaces with blank IP addresses. So now we see the F00 is using the IP address of 192.168.0.1. So everything looks good here. And we need to also configure the default route for this router so that whenever there is a packet destined to 172.168 network, so whenever the packet is destined to the new network, the router can forward the packets to the other router. So basically we are going to tell R1, the PC is going to send the packet to R1 because PC cannot reach the 172 address directly. So it is going to send it to the gateway, which is R1. And the R1, we are going to tell R1 whenever it sees a packet to 172, go and send the packets to the router at 10.0.1.2. Let's configure the routing for R1. Let's use a static route. So we're saying IP route. So whenever there is a packet coming as 192.168.0.2, we will say send the packets, route the packets to the network 10.0.1.2. So you have to say 0.0 there. So once that is set up, if you go to show IP route, if you look at the line there, it says whenever there is a packet, send it to 10.0.1.2. So whenever there is a packet in router destined for the network 172.168, it is going to send the packets to the other router. So now let's go to router 2 and configure there. First, let's configure the PC2 IP address, which is 172.168.0.2, and the default gateway for it will be 172.168.0.1, which is shown on the diagram. Okay, so I think it looks good. So the PC knows where to send if it cannot find the route for the network. And now let's go to R2 to configure the F00 interface and F01 interface. So we are already in the config mode. So let's go to interface F01. And let's plug in the IP 172.168.0.1. I wonder what's going wrong there. Oh, I know what's going on. I think I picked the wrong interface. It should be F01. So let's go and fix that. So let's go to the other interface. Yeah, I picked the wrong interface. So let's go and fix that. Interface F01. And the IP address for that is, again, we know that it's 172.168.0.1. Let's do a no shutdown to bring up the interface. Let's also configure the F00 interface, and the IP address for that is 10.0.0.1.2. Similar to the last router, we need to do a show route. Actually, let's check the IP addresses before checking the route to confirm that everything looks okay. I think we did a good job and configured correctly. So we need to configure the default route for the 192.168 address, so PC2 will know how to route it to the other network. So as you see in this annotation, that we need to set R2 so that the next hop will be the 10.0.1.1 network. So when R1 receives the packet destined for 192.168.0.2 address, it will know that it needs to send it to 10.0.1.1. So you can see that is why we need to pick 10.0.1.1 there. Okay, I think let's check that to verify. If you do a IP route, you can see there is an entry, a static entry there. So whenever there is a whenever there is a network flow from 192, send it to 10.0.1.1. So I think everything looks good. Let's try to ping from R2. Let's try to ping a couple of IPs on R1. So from R2 to R1, we'll ping address 0.1 from R2. So we're trying to ping it from there, because we need to check from the routers first before we go to the PC. So I think we're able to connect. Let's also try to ping the PC from router 2, so which is 0.2. I think the first one is going to be lost to ARP, so we get an 80%, which is good. So next time if you do it, I mean, you'll get a 100% response. So let's do the same thing in R1. Let's ping the routers. Actually, let's ping the PC IP address from R1. So again, you see the first one is lost to ARP, but I think it looks okay. And now everything looks good. So we should be able to ping from PC1 to PC2. Perfect. I think it looks good. Let's go to the PC2 so that we can confirm the routing is good from the other end. Okay, I think it looks good. So we have connectivity from PC1 to PC2 and PC2 to PC1. So let's capture the different legs and analyze using Wireshark. So my goal here is to explain ARP protocol and also ICMP request. So ICMP is invoked whenever you do a ping. So let's look both in Wireshark logs just to give you some basic understanding. So now that we have Wireshark launched, let's clear the ARP cache on the PC1, PC2, and also on the routers. Because whenever the networks talk to each other, they cache everything. So we may not be able to capture some traffic. By doing this, we should be able to see some ARP request, which you should be able to analyze. So let's ping the PC2. And I think we captured the logs. Let's go and stop all the Wireshark captures. We can also stop the capture from within GNS3. So let's look at, for example, the packet number. Look at the request, the first request, the PC1 to R1. So if you look at the diagram, so PC1 is trying to reach R1 and it doesn't know the MAC address of R1 because it is trying to reach the other network, but it doesn't know the route. So it is going to send it to the gateway. So all it knows is the IP address of the gateway, which we configured when we invoke the PC, but it doesn't know the MAC address. So you won't know how to reach the system. So it's going to send an ARP request asking for what's the MAC address, and it doesn't know where to send, so it is going to send a broadcast which is sent to all the nodes which are connected to the switch. So that is the request which says requesting for the ARP request. And if you look at the source, it's the source of the PC1 right there. And the destination is all Fs. Whenever you see all Fs in a MAC address, it means it's a broadcast packet. So all the PCs and networks connected to that switch will receive that request, and whoever owns that IP address is going to respond. So in this case, the router 1 has the IP address 192.168.0.1, so it's going to respond with its MAC address. So you can check the MAC address of router 1 is C2010B. So that's the source, that's the MAC address of the router 1, and that is the MAC address of the PC1. So once PC1 knows the MAC address of the gateway, it's going to send the ICMP request to the router. So next is the ICMP ping request. You can see that is going from our system, and then there is the IP address will always remain the same throughout all the routers, but the only thing that is going to change is the MAC ID, the source MAC ID and the destination MAC ID, and that MAC IDs are discovered using the ARP request in each of the networks. So there are 4 requests, and you can see 4 responses too. So let's analyze the second one, which is the traffic going from router 1 to router 2, and see if we can capture any, let's check and see if there is any ARP request in there. So like I said, the IP addresses will remain the same from R2 to R0. So basically the source IP will be 192.168.0.2 and the destination IP is going to be 172.168.0.2. So the only thing that will change is the MAC address. So in that leg, the source MAC address will be the router's F01's MAC address, and the destination MAC address is going to be R2's F00's MAC address. And the request, as I said, you can look at the source MAC IDs and destination MAC ID. So that will be of R1s and R2s. But the IP address, if you look at the source MAC ID right there, that's of R1, which you can verify using the show IP ARP command. And then the destination is going to be the MAC address of the R2's interface, F00 interface. Yeah, it's highlighted, like you see the IP address and the MAC address. So it's confirmed using the show IP ARP command as well. So the third Wireshark is the traffic captured from R2 to PC2. Again, like I said, the IP information is going to be the same, which is 192.168.0.2 and 172.168.0.2. So the only thing that are going to change in this third traffic is the source MAC ID and the destination MAC ID. Using the same techniques, you can verify the source MAC ID and the destination MAC ID. So 005079 is the PC2, which we can check in PC2. So look at the MAC ID right there. So in this demo, we looked at some basic static routing between routers. We also looked at ARP protocol and how it works. And we looked at some ICMP traffic that is going through the network. We also looked at how to analyze Wireshark and different protocols. So if you guys like this video, let me know. I can come up with more videos using GNS3 and Wireshark. And we can try to analyze and break up each protocol like DNS, DHCP, FTP, SSH, and so forth. So until next time, thanks everyone.